If you ever wondered how hackers know what's running on a network, like how they scan for open ports, figure out what services are running, or even identify the operating system of a target machine, well then in the next few minutes, you'll not only know how they do it, but you'll also be able to do it yourself. I'll show you how to use Nmap effectively to scan networks like a professional. Now, Nmap stands for Network Mapper. It's a powerful tool to scan devices on a network and gather detailed information. You give Nmap a target, like an IP address or domain, and then it starts probing the network. It pulls up information like what devices are connected, what services are running, which ports are open, and sometimes even the software versions or operating systems in use. It's used by system administrators, cybersecurity professionals, penetration testers, and even hackers, all for one main reason: to gather intelligence on a network, because knowing what's on a network is the first step to defending or breaking into it. Alright, first let's talk about scanning a target with Nmap. The basic command is simple. You just type Nmap followed by the target, and that's about it. When you run it like this, Nmap uses a SYN scan by default, which is also called a stealth scan. Nmap sends a SYN packet to each port on the target, and if the port is open, the target replies with a SYN ACK. Instead of completing the handshake, Nmap sends RSD, which is basically resetting and dropping the connection. Now this scan is useful because many systems don't log incomplete handshakes, so it's a good way to stay under the radar. Next is the TCP connect scan, which is specified with the ST flag. Unlike the stealth scan, this one completes the entire TCP handshake. Nmap sends a SYN and then gets a SYN ACK and then replies with an ACK to complete the connection. This is more obvious, so firewalls and intrusion detection systems are more likely to notice this. Aside from the TCP connect and SYN scan, Nmap has many scan types, and one other key type is the UDP scan, which can be used with the SU flag. Because UDP doesn't use a handshake, Nmap just sends a packet and then waits. If the port is closed, then you might get a port unreachable message, but if the port is open or filtered, then you might get no response. The tricky part is that no response doesn't always mean the port is open. It could also be a firewall blocking the packet, for example. And UDP scans are slower and less reliable without extra tools, but they're still important because essential protocols like DNS still operate with UDP. Before scanning ports, it's smart to find out which devices are actually online on a network. This is simply called host discovery, and you can use the SN flag to skip port scanning and just discover live hosts. This sends ICMP requests and other probes to identify devices, and it essentially saves time and lets you build a list of live targets before you start doing any deeper scans. By default, Nmap scans the 1000 most common ports. That's usually enough for a quick look, but with over 65,000 possible ports, so sometimes we need to be more specific because you might want to scan a specific port or maybe even a range of ports. This is where the P flag comes in. Let's say you want to scan one specific port like port 80 for HTTP, then you can use this flag followed by the port number like this. This would be quick, simple, and targeted. This is great if you know a service should be running on the network and you just want to verify if the port is open. If you want to check multiple specific ports, then you can separate them with commas like this command here. This would only scan those specific ports on the target system and nothing else. And if you want to scan a range of ports, let's say from 1 to 1000, you would then just use a dash between the numbers to specify the range. And finally, if you want to scan everything, then Nmap lets you scan all 6500 ports as well. To do this, you would just add another dash after the P flag, and this is going to be more time consuming, but it will make sure that you don't miss anything. When you scan a target, knowing which ports are open is definitely a good start, but it's just the beginning. To really understand what's going on, you also need to know what services are running on those open ports and what their versions are. This is where service enumeration comes in. It lets you get detailed information about the services behind those open ports, which could reveal vulnerabilities or specific configurations. Nmap helps with this using the SV flag. This flag does service version detection, which tries to identify the software running on each open port and figure out their version. For example, if you want to scan a target and find out what services are running along with their versions, you would run this command. This will scan all the open ports and then detect what's running on them. For example, if port 80 is open, it will tell you if it's running Apache along with the version number. And knowing the version is important because it can reveal vulnerabilities tied to that specific version of the software. You got open ports, you know what services are running, and maybe even the exact version. But here's the question, what kind of machine is the system? Like, is it running Linux or maybe Windows? This is very important. And this is where OS detection comes in. Nmap can actually try to figure out what operating system the target is using just based on how it responds to certain network probes. All you have to do is to add the -O flag, and behind the scenes, Nmap sends packets and watches how the target reacts. This can be really useful because if you know a specific exploit only works against Windows and then Nmap tells you the system type, then that's already a huge piece of information. Alright, now that you know how to scan targets, specify ports, or even identify services and versions, we can take this one step further because Nmap doesn't just stop there. You can run scripts that dig even deeper into a target system. These scripts are part of something called the Nmap scripting engine. They let you automate all kinds of tasks like checking for known vulnerabilities, grabbing banners, or doing brute force login attempts. And to get started with scripts, the most common flag is SE flag. This tells Nmap to run a default set of scripts which are useful and give you a solid overview of the target, like checking for anonymous FTP access, basic HTTP information, SSL certificates, that kind of stuff. And if you want to go even further and do a full deep dive, you can choose specific scripts using the script flag. There are many scripts available to us and each one is useful for a specific case. For example, if you run this command here, this one will grab the title of any web page running on the target's open HTTP ports. You can even stack multiple scripts by separating them with commas. Or if you want, you can also run entire categories of scripts. These scripts are extremely useful to us and you can find them in the Nmap scripts directory on your system. You can just browse through all of them to get an idea of what they might be doing. So at this point, we're detecting services, running scripts, checking for vulnerabilities. We're basically pulling as much intel as possible from the target. But here's the thing, once your scans start getting heavier, the performance becomes a real factor. The more ports, the more scripts, the more detail you ask Nmap to gather, the longer your scans are going to take. And sometimes that's exactly what we desire, but other times you don't want to wait 20 minutes for results. The easiest way to do this is with the T flag, which basically sets the timing template. These templates range from 0 to 5. So for example, if you're doing a quick internal scan and you don't care about the noise, something like T4 is your best friend. But if you're scanning over the internet or trying not to get flagged, you might want to stick to T2 or even T1. For example, if we run this command here, this would do a default script scan, detect versions, and do it all pretty fast. Using the right timing options can definitely make a difference, so these timing templates are a good piece of information to know. Sometimes speed is not the only thing that matters, because if you're scanning a network and you don't want to set off any alarms, then it's not just about how fast or slow you can scan, it's about how sneaky you are while doing it. Nmap has a bunch of features built in which lets you fly under the radar and avoid detection. And one of the most common tricks is using decoy IP addresses. You do this with the -D flag. Basically, Nmap sends your scan but also includes traffic from fake IP addresses. So the target sees multiple sources hidden at once. For example, if we run this command here, this will send a stealth scan from your IP address and 5 randomly generated decoys. Anyone watching your network logs is going to see 6 IP addresses scanning. You can also manually specify your own decoy IP addresses like this command here. The me part represents your real IP address and the rest are just noise. Alright, now let's say your scan finishes and you got a bunch of results flying across your terminal. They all look good, you see open ports, services, and everything you need is on the screen. But then you get distracted, or maybe you close the terminal, or maybe you just tell yourself to deal with it tomorrow. And then the next day you come back, but everything's gone. This is why you always want to save your scan results, and Nmap gives you a few simple output options to save the results in a specific format. So for example, if you're running a scan and you want to save the result like what you see on the terminal, you could just use the -on flag. This will save everything into a file which you can come back to no matter what happens to your terminal session. And this isn't just a nice to know thing, but it's the kind of habit that can save you when things go wrong. So always assume you might need to come back to it later. Alright, now if we take everything we've covered so far and put it all together in a full scan, we can craft something that can get us open ports, service versions, handles timing, throws in a little evasion, and even saves our results. So here's what each part does here. The -ss is simply specifying a stealth scan. The -p followed by another dash scans all ports from 1 to 65,535, and then the -se flag runs default scripts. The -sv flag detects service versions. The T4 basically boosts the scan timing to make it faster, and the -d flag allows us to add random decoy addresses for evasion purposes. And finally, the -on flag followed by the file name saves our results so we can review them anytime. This is still a very much of a basic scan, but it gives you a ton of useful information. So that was a quick overview of how Nmap works and how you can use it to scan networks. Nmap has a lot more under the hood, and if you ever get stuck or you need more information on any command, don't forget that you can always check the help page by typing nmap-h in your terminal. This will give you a full list of options or flags you can use. By now, you should probably have a solid understanding of how to gather intel on a network, and with the right combination of scans and techniques, you can just dig deep into any target. Just remember to always be responsible with your scanning and never scan networks unless you have explicit permission. If you liked the video, don't forget to like, comment, and subscribe. And as always, thanks for watching, and I'll see you in the next one.